This problem was asked in Russia National Olympiad, and the problem says let d and d dash be two divisors of n such that d dash is greater than d. Then you have to prove that d dash is also greater than d plus d square by n. So we have a number that is n, and this number can be divided by two another numbers, that is d and d dash. So d and d dash are divisor of n. This means if I multiply d with some number, I will get n. Similarly, if I multiply d dash with some number, I will get n. So let us see how we can solve this problem. Since d and d dash are divisors of n, I can have two integers, let us say k and m, such that if I multiply this by d, I will get n. And if I multiply m with d dash, I will get n. So what we have, n is equals to k times d or n is equals to m times d dash. So this is the definition of a divisor. That is, if divisor is d, if I multiply with some integer, I will get the number, and this some integer is k. Similarly, if d dash is the divisor, if I multiply d dash with some integer, let's say some integer is m, then I will get the number n. Now if I equate these two, that is kd is equals to md dash, and if I cross multiply, that is if I take m this side and k this side, so this becomes k by m is equals to d dash, and this d will come this side, so d dash by d. But in the problem it is given that d dash is greater than d. So if d dash is greater than d, this means d dash by d is greater than 1, because you can take this side. So d dash by d is greater than 1, this means k by m is greater than 1. So now I can say k by m is greater than 1, this means k is greater than m, because I can multiply m this side, and k and m are not negative numbers. They are integers, positive integers, because they are related to the divisors. So k is greater than m. Now k is greater than m. Now this can be greater than 1 unit, greater than 2 unit, greater than 3 unit. So k can be greater than m by 1 unit, 2 unit, 3 unit. But minimum it will be greater than by 1 unit. So now I can say k is greater than equal to m plus 1. So I have made an equality sign. So it will minimum be, k will minimum be greater than by 1 unit. In that case these two will be equal. Otherwise, if it is some other number, then in that case greater than sign will hold. That is, k is greater than equal to m plus 1. So we have this condition, that is k is greater than equal to m plus 1. Now let us multiply both sides by k. So this will become k square, and this side I will have mk, and this will be k. And of course k is a positive number, so sign will not change. Now as we know that k is greater than m, we have said this because d dash by d is greater than 1. From there I got the condition, that is k is greater than m. Then in place of this k, I can place a number m. But in that case equality will not hold, because I am going to put a bigger number. I am going to put a smaller number. So m is a smaller number, k is a larger number, bigger number. So if I am putting a smaller number, now this side will become a smaller. This means this will not be equal, this will be greater. So in place of k, I am putting a smaller number. So this means whole thing is a smaller. Earlier it can be equal to, but now this is a smaller, it can never be equal to. So this means this is greater than this number. Now let us put the value of k and m. So if you remember, initially I said n can be written as some number times the divisor d, some number times divisor d dash. So from here, if I equate these two, I can write k is equals to n by d. And if I equate this one and this one, I can write m is equals to n by d dash. So now I know value of k and value of m. So I can plug this value, because in the final equation I have to remove k and m. So let us plug the value of k and m. So k is what? N by d. So this is n by d whole square. And m is what? N by d dash. And k is what? N by d. And this is m, that is n by d dash. So this becomes n square by d square, n square by d times d dash, and this is n by d dash. And if you divide thoroughly by n square, so this n square will cancel, this n square will also cancel, and this n will cancel, and in the denominator I will have n. So now I have this condition, that is 1 by d square is greater than or equal to 1 by d times d dash, and this 1 by n times d dash. Now multiply both sides by d square times d dash. So that is d square by d dash, d square by d square times d dash, d square times d dash. So this d square cancels, this d and d cancels. So I will have, and d dash cancels. So I will have d, because d dash will cancel, and in this case again d dash will cancel. So what is left? So d square cancels, so I have only d dash, and here d and d dash cancel, so I will have d, and here I will have, because this d dash cancels, so I will have d square by n. So we have proved that d dash is greater than d plus d square by n. So I hope you like this problem, and if you like these problems, these videos, please share with your friends, like on my channel, subscribe to my channel, and I will see you in the next video. Thank you.